Good evening, everyone. Welcome back to our series of webinar on knowledge sharing. This is our 215th webinar in the last 2 years. We started broadcasting webinars. And wonderful topic. The first time we are talking about EV charging station, the safety and performance, the critical aspect of EV charging station. We are touching upon that. And my name is Dominic, your host for the today's webinar. As India accelerate towards a wide scale of EV adoption, the reliability and safety of our charging infrastructure become mission critical. Faulty installation, inadequate testing, and lack of awareness can lead not only to performance issue but also serious electrical fire safety risk. So today's discussion is aimed to bring bridging that gap. This webinar is brought to you in collaboration with our knowledge partner, Sonel India, a globally respected name in electrical testing, measurement, and diagnostic. We truly appreciate their commitment in advancing safe and high quality EV charging systems in India. So it's our great privilege to have with us Mr. Peter Polik from Poland. Unfortunately, the managing director of Sonel India, Mr. Sham Ravindran, who's supposed to take care of in an initial part, is unwell. So he will, though he is there, and he will not be, he's not in a position to present or involve in this discussion. So I encourage everyone to engage with our speaker. Please take notes and put your questions only in Q&A box. We have the look at and on the below bar you will find Q&A question box. Please put your Q&A box only in that. We will take up after Peter finishes his presentation. We'll take up the question. So let me introduce myself. I'm Dominic once again. You know, founder of FSCI, Fire and Security of India, one of the founding member of NFE, National Federation of India for Electrical Safety, and another founding member of Focus, Forum of Construction Utility Services, which is also talking about sustainable building, resilient building. So I'm also part of National Building Code Committee on Part 4. Uh, I wish we had our managing director, Sham Ravindran, also very well learned professionals, and he was there in our last webinar. I'm sure we wish him, all the speedy recovery. Wish him all the best to overcome the sickness that he's undergoing. He's in hospital today. Peter Pollack, who is also regular to our webinars. Probably this is sixth or seventh webinar that is joining to address the Indian engineers here. Peter graduate of the Faculty of Electronic at Warsaw University Technology. He has more than 10 years of experience in Sonel Group, an experienced specialist who constantly implemented the strategy of building export markets both in Europe and in the USA. He has collaborated on many training and marketing and sales projects. Peter actively participated in the implementation of new products. He collaborated on several new meter design, such as MPI 530 IT, multifunction meter, and Part 805 and 806, portable appliances tester, and adjusting our products to the US market. Peter is a specialist who willingly shares his knowledge and experience. He conducts online training programs and thanks to which webinar participants have opportunity to obtain professional knowledge without leaving home. He is mostly on online, going around the globe, talking to many engineers. Thanks to the training conducted by Peter, you'll deepen your knowledge today and operation of sonar meter and basic conductive measurement. In his spare time, Peter loves to travel, which allows him to meet new people and new places. He's quite regular to India and he understands the culture of India and the knowledge that Indian need on the subject of EV charging station, safety and performance, the topic of the webinar today. I would unshare my screen and I invite the speaker. Peter, over to you, Peter.
Okay, so hello everybody. It's very nice to be here again. Well, and today I okay, I will share my screen. Unfortunately, I have one screen at the moment. Okay, so here we are. Yeah, so today I'm going to talk about the safety and performance of electric vehicle charging stations. Okay, so well, the industry of electrical vehicles is growing, but there are also some hazards. Well, typically we can see from time to time news about some electric vehicle catching fire. Like here, I got some news from year 2022, where the electric bus in Hyderabad caught on fire. Or, well, also in 2022, there was some electric vehicle fire, which caused altogether about 100 vehicles to catch fire. And, well, this is the hazard, but what can we do to make sure that these fires don't appear and that we can improve the safety of the systems? Well, here the problems was some lack of protection of the systems. Another situation, well, here there was a fire in a dealership of electric scooters, and also it was blamed as a short circuit. So again, there were some troubles with the safety of electrical installations. Well, typically the reasons that would be for the fires would be either the condition of the battery inside the car, some problems with charging accessories, but these are the parts of car owner or the vehicle owner, or there could be some troubles with protection within electrical installation, so the infrastructure. And further reasons for that, there could be different environmental hazards, there could be aging, or there will be, well, just cutting some corners on a budget. Like, for example, a vehicle owner can get some cheaper charging cable, which may not necessarily be as safe as it's supposed to be. So right now, to make sure that our infrastructure is safe, we have all different requirements to help us improve the safety. Well, the first one that will be the Central Electrical Authority, measures relating to safety and electric supply. And here chapter 11 refers to electrical vehicles. Then further in the NEC, part 3, section 15 refers to electrical vehicles. And the whole Indian standard 17017 defines the conductive charging system for electrical vehicles. Well, so that's this. Of course, we have IS 732, which applies to, well, electrical installations in standard. And we have also different international standards defining charging, defining connections for electrical vehicles, defining different protections. Well, of course, all the requirements for testing and making sure that the charging stations work fine. Well, of course, the vehicle charging systems are evolving, and still all the standards are also evolving with them. So we need to keep eye out and make sure to follow different changes of those standards. Well, yeah, but generally, when we are thinking about electrical vehicles, we are thinking about the charging station and the car. But let's remember that there's all electrical infrastructure behind it. So we need to get power from the grid, through the transformer, then through some panels and meters, and then they will go to charging stations. So here, as per entire electrical installation, well, we have the CEA regulation, National Electrical Code, and well, general is the standard, Indian standard 732. And particular for the electric vehicles, in the CEA regulation, we have chapter 11. In the National Electrical Code, we have part 3, section 15. And we have standard IS 17017. So that's a little simplification, but we can see here which regulation applies to which part of the installation. Okay, so now let's look at electrical vehicles, what different types of charging we have. So there's AC charging mode 1. Right now it is obsolete. It was just a cable between a car or a vehicle or some scooter and outlet. But right now this mode is obsolete because we have mode 2, where this charging cable, or sometimes it is called a portable charger, has been equipped with a box with safety devices. So then in case of for example, short circuit, RCD can trip and it can disconnect the power. So that's the mode 2. Further, mode 3, that's AC charging in public places, and we can have 3 scenarios. Case A over here, that's also obsolete right now. That's when the charging cable was fixed to the car. Right now we don't have it. Usually cars only have a socket. So we have either case B or case C. So case B, that's where we have charging station with a socket, car with the socket, and a separate cable to connect the car. And case C, that's where the charging station has a fixed cable, and then we plug it in the car to connect it. And further on, mode 4, that's the DC charging. So here we have fast charging station. Usually, well, DC charging stations, they have AC part and the DC part because they need to rectify the voltage and currents coming from the grid. Okay, about the connectors, well, there are different connectors worldwide. In India, the most popular is type 2. So here we can see on the left there's the there's connector for the AC charging. So we have 3 phases. And on the other side, that's the one for the DC charging. So down below, we can see a DC plus and DC minus channels. Well, there are also some other plugs. I think Tesla has its own, which might be popular. But that's the most common type of socket, here in India. Okay, now about different types of connections. So like I said, in scenario when we can just connect the charger to the socket in the wall, we can have a single phase or 3-phase chargers. On the other end, they have a plug for the car with type 2 connector. And this charger is equipped with a box with safety breakers, so in case of any short, the power supply will stop. Then the other situation, that's where we have a charging station with a socket and car with another socket, and we are using a cable like you can see here in the middle. So it has type 2 connectors on both ends. And the first scenario, that's where the AC charging has a fixed cable. It just has a type 2 plug, which we can plug into the car. Then when it goes to a DC charging stations, well, they always have a fixed cable attached to the charging point, and we just connect it to the car. So that's how the equipment looks like. All right, so now to make sure that our vehicle charging is safe, we need to perform certain checks and measurements. So what do we need to check? Well, in case we are talking about type 2 charging, so that's when we have this portable charger, well, we need to check the diagnostics of control signals. We need to check different faults to make sure that there are no breaks in any of the wires inside our chargers, to make sure that the wires are not, they don't have switch places. And we also need to perform some measurements. So here we will check the parameters of residual current devices, the RCDs, including the 6 milliamp DC leakage current test. We need to make sure that the insulation of the cable is good, so the insulation resistance measurement. We need to check continuity of the wires, just to make sure that they are not broken inside. And in case we have a three-phase charging station, we need to check the rotation of phases. Now let's look at the charging stations. So here, what do we need to check on a charging station that looks like the one on the picture over here? That's the AC charging station. Well, again, we need to perform some diagnostics of control signals. So to make sure that station works correctly when in state A, so there's nothing connected. State B, that's connected, not charging. Then stage C or D, that is charging. And E, that's error. So we want to make sure that the station is behaving correctly in those situations. Okay, well, further on, in case we have some troubles, we can perform diagnostics of this control signal. So we can check its parameters or graphs. And we also need to make sure that transition between each state is going correctly. Further on, we need to simulate some faults and see how the charger is behaving. And we need to perform measurements. They are kind of similar like to regular electrical installations. So we need to check fault loop impedance. We need to measure parameters of the RCDs. We need to check insulation resistance, continuity. In case of three-phase charging stations, we need to check phase rotation, and check earth resistance of the charging station, but only in case it has earthing of its own. So, for example, when we have a charging station in a building, in some garage, well, then it's probably connected with earthing of the entire building. But when we have some charging station outdoors, it may have independent earthing. So in this situation, we need to check earth resistance of this earthing. Okay, now further on, in case of mode 3, where we have this scenario that the charging station only has a socket and the car has a socket, well, there also exists a cable for connecting the car to the charger. So in case of this cable, we need to check insulation resistance, continuity, and coding resistor. Well, here there aren't many tests. That's only we are just testing a cable. It does not have any breakers on it. It does not create any particular signals. It just communicates between the station and the car. So as a kind of, we can say, like extension cord. But yeah, here the measurements are pretty simple. And finally, we have DC charging stations, well, which takes AC power from the grid. Then there's the rectifier, and further on, they are connected to the car using the fixed cable. So what do we need to check over here? Well, the AC side, here we're going to need to check insulation resistance, fault loop impedance, RCD parameters, phase sequence test. Then for the entire station, we need to check continuity of the protective wires. And here there's a requirement to test it using a 10 amp test current. Well, further on, we need to check the SPDs, so surge protection devices. And in case the charging station has independent earthing, then we need to check its earth resistance. Okay, well, further on, we also need to check communications, transitions between the states. So similar like in case of AC station, but well, here the communication is a little different. Okay, so those were different stations and types of tests that we need to perform. So now let's go through all of these tests, see how to perform them. And of course, here I have the list of all possible tests. Like I showed you before, some of them apply to particular stations, some of them do not apply, but we are going to go through all of the tests that are possible. Okay, so first let's start with the visual inspection and diagnostic of control signals. So for the visual inspection, we check with all our senses to make sure that the charging station was constructed properly, that the right equipment was used, that it has been installed in a proper way. And also we will look for any obvious physical damages. So that's the visual inspection. Now on some meters you may find a checklist with different items that we need to verify. And further on we're gonna check different states to make sure that the communication is correct. So then we're gonna put our meters into different positions, simulating the car. So then when there is no connection, that's state A. Connected but without charging, that's position B. Then C or D, that simulates charging. C or D, depending if the station is with or without ventilation. And position E, that simulates error. And as we are putting our meter through all of these different positions on the control pilot, we need to check what is the reaction of our charging station, because they have different screens or different indicators. So we want to make sure that they work correctly. Now, as it comes to our meters at Sonel, because, well, we manufacture the meters, well, we have two solutions to check electrical vehicle charging station. One is a dedicated meter, which can perform all of the tests for electrical vehicle charging station, and that's the EVSC 100. So that's the name of the model. The other option will be to use the multifunction meter, so one of Sonel's MPI series, together with EVSC01 adapter. But okay, later I'm going to talk about equipment. Now over here we can see that on the meters we can simulate the CP, so the control pilot, at different states. PP, that's proximity pilot. So here we can simulate different maximum currents for the charging station. Also on the screen of the meter, we can see the values for the control pilot, so in volts. And further on with EVSC 100, we can also see the diagnosis and we can see the graph here of the control pilot signal states. So it's like oscillogram. Now further on, we can simulate different errors. So here we can check which type of error we want to simulate. We can simulate state transitions, and all of that will be recorded on the meter. Now, further on, another test, that's the continuity of conductors, of protective conductors. So we need to make this test for every station. And basically, this is a pretty easy test. Well, before we perform the test, we need to make sure to auto-zero test leads whenever it's necessary. So that's to get rid of the resistance of the test leads. And once this is done, we can perform the test. So we connect our test leads on one end and the other end of the conductor that we want to test. And here the requirements are that we need to have bidirectional flow of the current, so in one direction and then return. And the average of this resistance in forward and in reverse, that is going to be the value of resistance of the wire that we are checking. But, well, the point of this is to check continuity to make sure that protective wires are not broken. Now, further on in the IS standard 17017, there is the requirement that we need to test here charging station with a test current of at least 10 amps. So that's the requirement here. Now the next test, this is the insulation resistance. So here for insulation resistance, we're gonna need to adjust our test voltage. Well, so here we have a table from the standard, and well, depending on our nominal voltage, we are going to adjust the test voltage, and we have the requirements for minimum value of the resistance of the insulation. So typically, well, depending on the charging station, but if we have voltages up to 500 volts, we're gonna test the station with 500 volts DC. And minimum requirement for insulation resistance, that's above 1 mega ohm. And if we have charging stations with voltages above 500 volts, then we're going to need to test them with 1000 volts DC test voltage. And minimum requirement for insulation resistance is again 1 mega ohm or higher. Well, now here the complication will be that, well, if, for example, we have a three-phase AC charging station, it has many channels on its plug. So to connect between each pair of the wires inside this connector can take a lot of time. So at Sonel, the meters, they have automatic test sequence here for insulation resistance. And so once you connect the meter to the socket on the charging stations or to the cable on the charging station, it will automatically perform insulation resistance measurement between each pair of the wires. And on the meter, like you can see here, we can check the right boxes before the measurements, which wires we have in a charger, what is the configuration here. And after the measurement, we will see the list with the results with all of the combinations. And further on the meters, we can put the limits for our insulation resistance measurement. So here that would be 1 mega ohm. And once the measured value is above this limit, the meter will automatically evaluate the results. So if everything is in green, that means it's good. Okay, so yeah, thanks to using this special algorithm, all the insulation resistance tests are just faster because the meter does all of the combination itself. We don't need to connect, disconnect, and connect then to another pair of conductors. Okay, then the next test, that's the effectiveness of electric shock protection. So that's the fault loop impedance measurement. Uh, okay, so we're gonna do this on AC charging stations or the AC part of the DC charging stations. Now, why do we need to perform this measurement? So if everything is work fine, then the currents supplying our chargers, they flow from the phase channel through the charger, and then we turn on the neutral channel. But what happens in case we have a fault situation? Well, then some potential can appear on the cover of our charger. And here the cover should be connected through the protective wire PE, either back to the transformer or to the earth. So we are going to have some leakage currents flowing through PE wire or flowing through earth, or in a situation where somebody will be touching the cover of the charger, then the leakage currents can flow through their body, and this person can get shocked. So, in order to avoid this situation, we are putting overcurrent protection here. And there's one job of this overcurrent protection. So, in case we have some leakage currents and they are higher than the current triggering this breaker, then the breaker is going to trip and automatically disconnect the power. So the whole point here is when we have a fault situation in our electrical installation, then breaker disconnects this power, so we can avoid shock to the people. We can avoid any overheating and fires caused by high leakage currents. Okay, so that's the whole idea. Well, measuring this leakage current or the fault current itself would be very complicated. So that's why the meters, they measure fault loop impedance. And further, as we know, well, the value of the impedance and the value of supply voltage. So this is going to be our fault current. And then we compare it with the specs of our breaker. If this fault current is higher than current triggering the breaker, then the whole situation is correct. So here, our meters from Sonel, they can perform such measurement. So first we need to remember to put a charging station in a certain condition, because we perform this measurement on live circuits. So the station needs to be in charging mode. So it needs to be charging at the moment. And then the meter can perform the measurement. Also, once we put the type of the breakers to the meter, it will automatically evaluate the result after the measurement. Okay, then next tests, that will be operation of residual protection devices, so the RCDs, and to check leakage currents above 6 milliamps DC. So here the RCM. Now here, what is special about charging stations for the vehicles comparing to regular electrical installation is that the National Electrical Code require us to use the RCD of type B or type A with additional protection against leakage currents above 6 milliamps DC, or RCD of type F, again with additional protection against leakage currents above 6 milliamps DC. So here, this additional protection needs to comply with the international standard IEC 62955. Okay, so now why it is so complicated? Why do we need this special type of breakers? Well, okay, so the battery in the car is always being charged with the DC currents. So there's a rectifier somewhere on the way, either in the car, in the vehicle, or if we have DC charging stations, then it's going to be inside the charging station. But whenever we are going to have some fault currents, leakage currents, they will not have a nice AC sine wave. So that's why we need to use different types of RCDs. And here, type B, it allows us to, well, it will trip whenever we have sinusoidal AC currents, pulsating DC, smooth DC, or a composite of multi-frequency. So whatever leakage current we are going to have, then the RCD is going to trip in case of a fault situation. Then for RCD type F, it's going to trip for sinusoidal AC currents, pulsating DC, or composite of multi-frequency up to 10 milliamps. And type A will work for sinusoidal AC and pulsating DC up to 6 milliamps. So that's why also we see that for type A and F, we need additional protection. And here the international standard IEC 62955 describes how to test these protections. Or, well, standard 62955, this is for mode 3 charging, so wherever we have a public AC charging station. But for mode 2, so when we have these charging cables with the box with breakers with the RCDs, here applies the IEC 62752. Well, and to simplify the reason here how to perform the testing for each of the standard, well, then we're going to have 6 milliamps DC current, and depending on the standard, we need to multiply it by 1, 10, 33, or 50 times. And the standards define how quickly the RCD should work. So you can see the requirements here in this table. Okay, now as it comes to the meter, we can define the automatic RCD tests. So we can select the type of RCD here for the electric vehicle, and we can check the triggering current as well as triggering time for nominal currents times half, 1, 2, 5, 10, 33, or 50 times. So depending on the type of applicable standard, we can perform all of the necessary tests within the meter. And at the end, we will just have a list of the results. Now, this is natural that during the test, the RCD is going to trip a few times, which is normal. We just need to put it back on, and the meter will automatically continue the tests. Okay, further on, in case of the DC charging stations, we have surge protection devices, so the SPDs, and we also need to test them. Well, here the idea of the SPD is in case we have some higher pulse on one of the channels, then the protection device is going to connect both channels, so they would be on a same potential, and therefore it will prevent damage to connected equipment. And here we have another standards which are defining types of the SPDs. Well, typically in case of vehicle charging stations, we are going to have SPD type 2. And here, well, we're going to need additional meter, like for example at Sonel we have MIC 2511, so that's the model. That's the insulation resistance meter, but it can also check the SPD, so surge protection devices. We need to connect test these between plus and minus, and then the meter performs the test for us, and it will show us all of the different values that it can measure, which we need to compare with the specs of the SPD. Okay, then we have next test, which is phase rotation. Well, that's in case of three-phase AC charging stations. or in case of the DC charging stations, but just their AC part. Well, and here we just need to connect the test leads and to make sure that the voltages for each phase are rotating in the right direction. Okay, and finally, earth resistance measurement, but that's only in case the charging stations has its own independent grounding. In case the charging station is, for example, in some garage, in a building, then we just need to check continuity to make sure that the earthing of the charging station is connected correctly with the earthing of the entire building. But when the charging station has earthing of its own, we need to perform the tests. Well, and here, depending on the meter, we have different tests available. Well, here I have example with the test where we are using the rods. Oh yeah, and well, these are all of the tests that we need to perform for charging stations. Now, the meters, they allow you to create a sequence of different tests, which are performed later automatically. And at the end, you can see the summary of the results. Okay, so now let's look a little bit at the test equipment. So that's what we do at Sonel. And here I would recommend using two meters, the EVSC 100 meter. That's the standalone meter designed to check electrical vehicle charging stations and their safety. So we just need 1 meter. Maybe in case of a DC charging stations, we might want to use additionally MIC 2511 insulation resistance meter to check the SPDs. And the micrometer, that's as it has higher test currents to check continuity. So at Sonel, that's MMR 640. And further on, if you would like to check, if we are checking different electrical installations and charging stations is just part of our job, then you can use the multifunction meters of MPI series together with EVSC01 adapter. Okay, so now let's look a little bit at the meter. This is the EVSC 100. So that's a standalone meter. It's not, you don't need some meter and this has to work as the adapter. It's just a meter of its own. Well, here's the charging socket, safety fuses. We operate the meter using touch display or the buttons. And in the future, there will be also an app, so we would be able to remotely control the meter. Now here are the in sockets, and this is a single phase, three phase, or a type 2 socket. The out socket is on the side of the meter. And further, for leakage current measurements, we have additional wire here on which we can put a clamp multimeter to check leakage currents. Here is additional socket for communication with external oscilloscope, and for communication with computer we have USB sockets, LAN cable, or some other additional USB sockets, for example, for a thumb drive or a barcode printer and scanner. Okay, here on the side this is an out socket, and this is a type 2 socket. Now, as it comes to different measurements and diagnostics that the meter can do, well, it can simulate different currents for proximity pilot up to 80 amps. It can simulate different states for communication, and it can simulate different faults. Now, well, here we can see the list of all of these different faults. So we can simulate breaks in different circuits, or we can simulate interchanged different wires. As it comes to the measurements, we can check fault loop parameters, RCD parameters, including the RCM, insulation resistance, continuity measurement, earth resistance, phase sequence, phase rotation. We can check voltage on the control pilot. We can check frequency. We can check signal filling. So that's the oscilloscope for the control pilot. And we can check the turn off time. Now, another solution that's using a multifunction meter together with the EVSE01 adapter. So here, the adapter, this is just the interface between the meter and the charging station. So on one end, it has a multi-plug, which we can connect into the meter. On the other end, it has a Type 2 connector. And again, an adapter allows to simulate different states and different currents up to 63 amps. So that's for control pilot and proximity pilot. And it can perform different measurements. So fault loop impedance, RCD parameters of different types of RCDs, insulation resistance, continuity, phase rotation, and we can create automatic sequence of measurements. So then we don't need to go to a different measurement function. Once we set up this sequence, the meter will just go in a sequence with all the designed measurements. And here, while adapter is just the interface between the meter and the charging station, the meters that can work with this adapter are our multifunction meters of NPI series, model 535, 530 TPV. Okay, so now let's look at the application and which meters we can use. So first, whenever there's an electrician who checks the infrastructure, so they worry about the socket in the wall, about the charging station, but not necessarily about the cars and remote chargers and cables, which are the accessories of the vehicle owner. So just the infrastructure. So here, well, depending if we are checking different electrical installations, and only sometimes we're gonna check a car charging station, then we can use a multifunction meter together with EVSE01 adapter. And further on, for the DC charging stations, we're gonna need MIC2511 and the micrometer MMR640. So that's to check SPDs and to check continuity with higher currents. Now, on the other hand, when we are mostly checking charging stations, then we can use the EVSC 100 meter. And in case of DC charging stations, additionally, we're going to need the MIC 2511 to check SPDs and the micrometer to check continuity using higher currents. Now, further on, when we are checking the charging stations more often, but sometimes we want to check the regular electrical installation, then the EVSC 100 meter has in standard a special adapter which changed the output plug from Type 2 into just banana connectors. And later we can connect regular test leads and check any electrical installation, like for example, single phase or a three-phase socket, well, then using just the test leads and pin props. Okay, now here I put asterisks. So in case our charging station is very close to a transformer, then fault loop impedance may want to have some very small values. So then we won't need to use some more precise meter. But that's in a very particular cases. So here we have high current fault loop impedance meters of MZC series. So at least that's going to be 310 or 320 or some higher models. Okay, now let's look at another application. So here, this is whenever we are working in car repair workshops, some well facilities where we check electrical vehicles. Then we do not care that much about the infrastructure. We just take care about the parts that the vehicle owner has. So here we will check charging cables or remote chargers. And for this application, all you need is the EVSE 100 meter, just on its own, as we can connect a charger to the socket on one end and to the socket on the other end, and therefore perform all of the tests of this remote charger or of a charging cable. Okay, now these were all for all measurements of electrical safety, but we have some other measurements, like there's requirement to check the light intensity at a meter reading area. That is described by the IEC 12464. And here this is generally for fueling stations. The standard does not differentiate if the fuel is a gasoline or electricity or any other type. It just said it's a car fueling station, and here a meter reading area needs to have at least 150 lux of light. And here the possibilities are either to use Sonel multimeters of LXP series, or whenever you have the multifunction meter, you can get the lux meter probe, which is optional accessory to this meter, and we can perform the light intensity measurement. Okay, so these are all of the measurements to check the safety. Now at the end, we need to create some sort of a report, and for that we have a software. There's Sonel Reader software, which is a free software, and it allows you to download all of the data from the meters to your computers and later export them to Excel file, text file, HTML file. The other software is Sonel Reports Plus. Now this software is chargeable. It can also read data from the meter, but it allows to perform the report as per applicable standards. So that's the difference here. Well, you can also check the demo version free of charge. You can download it from our website. And the difference between the full version and the demo version, that's that you cannot put the name of the test technicians in the demo version. And all of the printouts have a big demo sign. So that's the difference between demo and the full version. But still, if you are wondering about purchasing the software, you can download the demo version and experience it. Okay, so that was about the safety. Now let's look a little bit at the diagnostics. Well, so first of all, what comes to our minds, that's power quality. And here, well, at Sonel, we can have two group of meters. One, like the PQM 750 over here, this is the permanently installed meter. So we can install it somewhere, for example, near a transformer station or on some switchboard, which is powering the vehicle chargers. Or we have a portable meters, so then in case we have some anomaly, we can temporarily connect the meter, record the quality of the power, and later take down the meter and analyze what's going on in our network. And typically what's important here for the vehicle charging stations, well, one, this is the power that is supplied from the grid, but it's not different from, well, supply power for any other type of applications. And the other thing will be different anomalies occurring at the charging station and later being transmitted into the grid. So here, well, the battery in the car is always charged with the DC currents, so there's always a rectifier. It could be in a charging station when we have DC charging station, or it could be in a car whenever we have AC charging. But rectifiers can create harmonics, so we need to monitor for harmonics. Other thing that would be powers and energies to make sure how much power well our charger is using, to make sure we do not create too much of reactive power, because then we can get some penalties from the utility that is supplying the power. And one more thing, we can look also at our three phases, if they are symmetrical, to make sure that there is no unbalance between between different phases. Here that will apply to a three-phase charging station. or wherever we have multiple single phase charging stations. Okay, further on for diagnostics, we can use thermal imaging cameras. Well, here at Sonel, we have different models of the cameras. The whole series of thermal imaging cameras is called KT. And as we will be checking charging stations, well, the basic idea is whenever electrical elements overheat, then they are faulty. So we will be just looking for overheating breakers, connectors, well, and other parts. But well, yeah, thermal imaging camera might be useful here. Just remember there need to be load connected, so there need to be a vehicle connected and charging. Otherwise, when there is no load, well, we will not be able to detect this overheating and therefore detect different faults. Okay, and further on, this is more for the vehicle repair shops. Well, the vehicles have batteries, and we need to inspect different parameters of the battery whenever it is failing, or we just want to make sure that it's safe. And here, for that reason, at Sonel, we have a battery tester. So that's the meter called BT120. Okay, so I'm getting to the end. Right now, we are just slowly running out of time. So that's the end of my presentation here. And okay, let me stop sharing screen. Oh yeah, so that was my presentation here.
Hi, Peter.
Mhm.
Thanks. Thank you, Peter. I would like to invite the audience who wants to put up a question to Peter. Use the Q&A box. There is a Q&A box. You can ask this question related to today's topic. So we will take this one by one. So there are certain, chat box. I can find some questions. If you can put that in the Q&A box, I'll take it down. Okay. Emmanuel from Ghana. Oh, nice. The people from South Africa was joined. People from Dubai, they have joined.
Mhm.
Okay, good to see people coming from all over. So I invite people to put their questions here. I will take the first question. Hope that can be answered by Peter. Gautam Kamath is asking, do we need to earth the body of the charging station in case of individual parking in apartments?
Well, yes, we need to provide earthing to the charging stations. Uh, now, the question will be, for example, when we have apartment building and in garage there are chargers, we can connect charging stations to the earthing installation of the entire building. So they don't need individual earthing. Yeah, we can just connect them to the earthing installation of the building. But definitely we need the earthing because in case of a fault situation, we can have some potential on the cover, and then the protective earthing wire will lead this potential to the earth, to the ground. Otherwise, in fault situation, when a person touches the cover, they will get shocked. So we don't want that. But well, yes, we need earthing. Here, depending on the project and on the type of the building infrastructure, well, in case of apartment buildings, we can connect this to earthing system of the building. In case we have, I don't know, some, for example, rest station and the motorway in the fields, then, well, I believe that the charging stations will need to have their individual earthing system.
Yeah, thank you, Peter. There is Sambandam who's appreciating the PPT. Looked like he's a teacher, a faculty member. He says, if I can get your PPT, he can take this to students for training and learning. I'll request Peter if you can share the PPT to my team. I will share it to all the members who attend it. Anil Jain is asking, is there mandate perform set tests regularly at fixed interval on charging stations?
Mm, Okay, so I know that there's well, there are two types of tests. First one, this is the acceptance tests. So we need to perform it every time the new charging station or new electrical installation is being constructed and before it is handed over to the user. So that's why we test everything that it was constructed correctly and it works correctly. And later we have another types of tests, which is periodic testing. So here we come every period of time to make sure that the equipment is still safe and it has not deteriorated with the time. Okay, and for that we need interval. Well, yeah, and it is defined, but it depends here on different situations. Well, for example, if we would have a standalone charging station in a field, we would need to test it every year. I'm not entirely sure about the period for the charging stations within the buildings, because it may depend on the electrical installation of the building. So well, here we just think about the charging station like, so say, some type of a socket within the electrical installation. So for the buildings, I would need to look into particular building and particular code to make sure how many years we need in between the periodic inspections. So yes, it is defined, but I would need to verify applicable standards. Like at the beginning of the presentation, I showed you the standards.
Yeah, they kindly tell us about safety. I think that was the presentation, the topic of that about the safety in the charging station. I will just dismiss the questions here. Uh, And in India, BIS mandate EV charges and charge. Yes, it is mandate EV charges and charging station. With more detail, I'll get our BIS person to answer to you over the over the mail later. And then I will get back to you on this.
So that's the Bureau of Indian Standards, yes?
Yeah,
So the
beautiful understanding. So more
certification.
questions from
Mhm.
again, Sambandam is asking, where fire incidents in India due to unsafe practices, poor, spurious product, and used charging interlock failure? Please, briefly. So, how do you
Mm.
understand the spurious or now product about the charging? You said cable torn up, poor cabling, how do they know as a user? Can
Mhm.
they identify?
Well, yeah, I know that's a pretty wide subject here because, well, us as electricians, we understand the whole environment, but there could be vehicle owners which are not electricians. And they could have, different professions. They could be good at whatever they do. There could be smart people. But for example, they may not have the necessary knowledge about the using of electrical devices like the cars. For example, when the car battery, which is at the bottom of the car, might be dipped in some water, because I don't know, there was, for example, some monsoon or something, and it happens too often, then the battery can get damaged. Here I know that the vehicle manufacturers, they do different things to prevent this. Other thing may happen, like some poor practices. Whenever we have chargers, remote chargers, or charging cables, then the car owners, they want to, save some money, and they buy a little bit cheaper charging cable. But then the connectors might be loose, and there will be overheating, which can lead to some fire again. Other situations. Well, here, let's say some homemade electricians, they sometimes see breakers that they cause the problem because they break the power. Well, the whole reason for the breaker is to break the power in case of a problem. So missing the power here is not the problem itself, it's just the solution to provide a shock. but some homegrown electricians can put oversized breakers, or they can try to breach the breakers. So we also do not want that. Or maybe I'm saying homegrown electricians. Sometimes this might be just some regular people who will own a charger. They will try to somehow. mm breach the breakers, and then in case of a fault situation, the breaker will not disconnect the power, and that's going to lead to a fire or some electric shocks. So we don't want that. Well, yeah, so I would say these are like some, basic situations.
Yeah, thank you, Peter. I think with that we end this session. It's 1 hour, 10 minutes. And we look forward to see you in our next webinar. I'll discuss with Sham and see what's the topic that we can cover next time.
Mhm.
Um, Overall, the rating is good. The feedback is very positive. And we also given you the Peter Pollock mail ID. Those who wants to write to him, um, the chat box you can see his mail ID. You can directly write to him, get more clarity. So thank you very much for joining for today's program, and thank you Sonal for coming for the knowledge partner. And Peter joined us from Warsaw, Poland. And thank you for him for all the effort that he have taken to do the presentation today. So looking forward to see you in the next webinar, Faith Meets Technology. Very interesting topic that we are covering, Faith Meets Technology. We have a lot of snippets happening, Peter, in the crowd classes. So we would like to see how technology can be implemented and uh, and reduce the accident, the loss of life in the crowded, whether it could be churches, temple, mosque, and all that. We gather in thousands of people. So how do the technology help? So we have a webinar called Faith Meets Technology next Friday. So that's why. So I'll see you once again. Looking forward to see you more webinar coming from Peter. Thank you, Peter. Have a wonderful weekend. Look forward to seeing you. Thank you. Bye bye.
Thank you very much, and a great weekend to everybody. Thank you.
Thank you.
Take
Bye
care.
bye.